Sequence. A sequence may be generated from shapes, patterns, or rules. Each number or element in a sequence is called a term. Example: find the next term on the given sequence 0, 4, 8, 12, 16. The next term is 20. Did you get the pattern? The pattern is 4 is being added to each term. Number 2 example, find the next term on the given sequence 1, 4, 9, 16. The next term is 25. Did you get the pattern? The pattern is each term is a square of a number. It's your turn. Find the next term of the following sequences. Number 1, 5, 8, 11. 2, 16, 48, 80. Number 3, 2, 6, 10, 14. Number 4, 10, 7, 4. Number 5, 7, 12, 17, 22, 27. Are you done answering? Let us see if your answers are correct. 1. The answer is 14. 3 is being added to each term. 2. 112. 32 is being added to each term. Number 3. 18. 4 is being added to each term. Number 4. 1. Negative 3 is being added to each term. Number 5, 32. 5 is being added to each term. How was it? Are your answers correct? Let's practice. Find the next term in each sequence. Number 1, 2, 5, 11, 23. Answer is 47. Each term is doubled then added by 1. Number 2, 2, 4, 16. The next term is 32. Each term is multiplied to itself. Number 3, 7, 13, 19. The next term is 25. 6 is being added to each term. Number 4, 19, 16, 13. The next term is 10. Negative 3 is being added to each term. Number 5, 3, 6, 12, 24. The next term is 48. Each term is multiplied by 2. Want more? Time to master it. Number 1. Find the next term in the given sequence 10, 11, 9, 12, 8. The answer is 13. Number 2. 2, 2, 4, 6, 10, 16. The next term is 26. Number 3. 1, 1, 2, 4, 7, 13. The next term is 24. Number 4. 3, 5, 7, 9, 11. The next term is 13. Number 5, 13, 26, 39. The next term is 52.
Writing the first nth elements of the sequence whose general term is given. Let me give you some examples. Write the first four elements of a sequence whose general term is a sub n is equal to 3n. For the first term, substitute 1 to n so that we will have 3 times 1 is equal to 3. So 3 is the first term. By substitution, the second term will be 6, the third term will be 9, and the fourth term will be 12. So the first four elements of a sub n is equal to 3n are 3, 6, 9, and 12. By this time, let's have the first 5 elements of a sub n is equal to 2n minus 1. For the first element, substitute 1 to n so that will be 2 times 1 minus 1 is equal to 2 minus 1 which is equal to 1. So the first term is equal to 1. By substituting consecutive integers, the second term will be 3, third term will be 5, fourth term will be 7, and the fifth term will be 9. So, the first 5 elements of a sub n is equal to 2n minus 1 are 1, 3, 5, 7, and 9. How about the first 3 elements of a sub n is equal to n squared minus 5? By substituting 1 to n, we will have 1 minus 5 which is equal to negative 4. For the second term, since 2 squared is equal to 4, the working equation will be 4 minus 5 which is equal to negative 1. For the third term, that will be 3 squared minus 5 or 9 minus 5 which is equal to 4. The first 3 elements of a sub n is equal to n squared minus 5 are negative 4, negative 1, and 4. Let's now look for the first 3 elements of a sub n is equal to 5n squared minus 5. Since we're looking for the first term, substitute 1 to n, that will be 5 times 1 squared minus 5 which is equal to 5 times 1 minus 5 which is equal to 5 minus 5 and that is equal to 0. Following the same process, the second term will be 15 and the third term will be 40. The first 3 elements of a sub n is equal to 5n squared minus 5 are 0, 15, and 40. Now, let's try it. Write the first 5 elements of the sequence whose general term is given above. A sub n is equal to 2n plus 1. Let's see if your answers are correct. The first 5 elements are 3, 5, 7, 9, and 11. How about the first 5 elements of a sub n is equal to 1 minus 3n? Answer: negative 2, negative 5, negative 8, negative 11, and negative 14. What are the first 5 elements of a sub n is equal to 5n plus 2? Answer: 7, 12, 17, 22, and 27. Write the first 5 elements of a sub n is equal to 6n minus 5. Answer: 1, 7, 13, 19, and 25. What are the first 5 elements of the sequence a sub n is equal to 4n minus 12? Answer: -8, -4, 0, 4, and 8. Want more? Try this. Write the first 4 elements of the sequence whose general term is given above. A sub n is equal to n squared minus 2. Answer: -1, 2, 7, and 14. How about a sub n is equal to 2 minus n cubed? Answer: 1, -6, -25, and -62. A sub n is equal to n squared plus 3. Answer: 4, 7, 12, and 19. First 4 elements of a sub n is equal to n to the 4th power minus 1. Answer: 0, 15, 80, and 255. The first 4 elements of a sub n is equal to n squared minus 8. Answer: -7, -4, 1, and 8. Thanks for watching! What are the 3 arithmetic means between 4 and 32? Answer: 11, 18, and 25. Solution: by using the formula of an arithmetic sequence, a sub n is equal to the first term plus the quantity of n minus 1 times the common difference, we can say that the last term is 32 and the first term is 4. Since we are to insert 3 arithmetic means, meaning to say we have a total of 5 terms in the given sequence. By substitution, 32 is equal to 4 plus the quantity of 5 minus 1 times the common difference. Then, 32 minus 4 is equal to 4d. 28 divided by 4 is equal to 4d divided by 4, meaning to say the common difference is 7. Remember that an arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. By adding 7 to each term, the second term will be 11, third term will be 18, and the fourth term will be 25. Therefore, the 3 arithmetic means between 4 and 32 are 11, 18, and 25. If 3 arithmetic means are inserted between 11 and 39, find the second arithmetic mean. Answer: 25. Solution: remember that arithmetic means are the terms between any 2 non-consecutive terms of an arithmetic sequence. By using the formula, a sub n is equal to the first term plus the quantity of n minus 1 times the common difference, we can determine the common difference by substituting 39 to the last term, 11 to the first term, and 5 for the number of terms. The working equation will be 39 is equal to 11 plus the quantity of 5 minus 1 times the common difference. By addition property of equality, 39 minus 11 is equal to 40, and 39 minus 11 is equal to 28. By dividing both sides by 4, we will have 7 as the common difference. By adding 7 to the first term, the first arithmetic mean is 18, the second arithmetic mean is 25, and the third arithmetic mean is 32. So, the second arithmetic mean is equal to 25. Insert 4 arithmetic means between 13 and 33. Answer: 17, 21, 25, and 29. Solution: first, we need to get the common difference by substituting 33 to the last term, 13 to the first term, and since we are to insert 4 arithmetic means between 13 and 33, we have a total of 6 terms. The working equation will be 33 is equal to 13 plus the quantity of 6 minus 1 times the common difference. It will be 33 minus 13 is equal to 5d. 33 minus 13 is equal to 20. By dividing both sides by 5, we have d, or the common difference, which is equal to 4. By adding 4 to the first term, the first arithmetic mean is 17, second arithmetic mean is 21, the third is 25, and the fourth is 29. So the 4 arithmetic means between 13 and 33 are 17, 21, 25, and 29. Find the missing term of the arithmetic sequence 28, 38, blank, 58, and 68. Equal to 48. Find the missing terms of the arithmetic sequence negative 34, negative 44, blank, and blank, negative 74. Answer: negative 54 and negative 64. The common difference is negative 10. Find the missing terms of the arithmetic sequence 35, 39, blank, blank, and 51. Answer: 43 and 47. The common difference is 4. Find the missing terms. Negative 21, negative 51, blank, blank, and negative 141. Answer: negative 81 and negative 111 since the common difference is negative 30. Find the missing terms of the arithmetic sequence negative 31, blank, blank, negative 52, negative 59. Answer: negative 38 and negative 45. The common difference is negative 7. What is the arithmetic mean between 16 and 26? The common difference is 5, so the answer is 21. How did I do that? I just simply subtract the first term from the last term, and since we only have one arithmetic mean missing, meaning to say we only have 3 terms, so that is just 3 minus 1 times the common difference. So, the difference between the 2 terms given divided by 2 is equal to 5. Since the common difference is 5, 16 plus 5 is equal to 21. What is the arithmetic mean between 19 and 31? Since the common difference is 6, the answer is 25. The common difference is 3. The answer is 12. Since the common difference is 2, the answer is 3. common difference is 5, since 22 minus 12 is equal to 10 divided by 2, and 12 plus 5 is equal to 17. Insert two arithmetic means between 5 and 65. Since the common difference is 20, the two arithmetic means between 5 and 65 are 25 and 45. Since the common difference is 8, the two arithmetic means between 1 and 25 are 9 and 17. What is the sum of the integers from 1 to 50? If the first and the last term are both given, use the formula S sub n is equal to n over 2 times the quantity of the first term plus the last term. Since we're looking for the sum of integers from 1 to 50, the number of terms is equal to 50. So, we have S of n is equal to 50 over 2 times the quantity of 1 plus 50. And 50 over 2 is equal to 25, and 50 plus 1 is 51. So 25 times 51 is equal to 1,275. So the sum of the integers from 1 to 50 is 1,275. What is the sum of the first 25 terms of the arithmetic sequence 4, 9, 14, 19, 24, and so on? If the last term is not given, we may use the formula S sub n is equal to n over 2 times the quantity of twice the first term plus the quantity of n minus 1 times the common difference. Using the given, n is equal to 25, the common difference is 5, and the first term is 4. By substitution, the working equation will be S of n is equal to 25 over 2 times the quantity of 2 times the first term, which is 4, plus n, which is 25 minus 1 times the common difference, which is 5. This will be 25 over 2 times 8 plus 24 times 5. So, 25 over 2 times the quantity of 8 plus 120 is equal to 25 over 2 times 128, or equivalent to 25 times 64, and 25 times 64 is equal to 1,600. Therefore, the sum of the first 25 terms of the arithmetic sequence 4, 9, 14, 19, 24, and so on is equal to 1,600. First, get the number of terms by using the formula n is equal to the quantity of a sub n minus a sub 1 over d plus 1, where a sub 1 is the first term, a sub n is the last term, n is the number of terms, and d is the common difference. By substitution, the last term is 500 and the first term is 100 and the common difference is 1. So this will be 500 minus 100 over 1 plus 1. That will be n is equal to 400 plus 1. So the number of terms is 401. To get the sum, we will use the formula S sub n is equal to n over 2 times the quantity of the first term plus the last term. By substitution, we have 401 over 2 times 100 plus 500. That will be 401 over 2 times 600. 401 over 2 times 600 is also equivalent to 401 times 300. And 401 times 300 is equal to 120,300. Meaning to say, the sum of the integers from 100 to 500 is equal to 120,300. What is the sum of the first 50 odd integers? To get the sum of odd integers, just use n squared. So, the sum of the first 50 odd integers is equal to 50 squared, or 2,500. How about the sum of the first 50 even integers? To get the sum of even integers, just use n squared plus n. Since we're looking for the sum of the first 50 even integers, that will be 50 squared plus 50. We all know that 50 squared is equal to 2,500 plus 50, that is 2,550. So the sum of the first 50 even integers is equal to 2,550. What is the sum of all the odd integers between 8 and 26? Answer: 153. Solution: first, get the number of terms between 8 and 26. Formula will be n is equal to the last term minus the first term divided by 2 plus 1. Why is it that we need to have it divided by 2? Since we're looking for the sum of all the odd integers between 8 and 26, we can observe that the common difference between each term is 2. The last odd integer between 8 and 26 is 25, while the first integer between these two given numbers is 9. By substitution, the quantity of 25 minus 9 divided by 2 plus 1. So 25 minus 9 is equal to 16, divided by 2 is 8, plus 1 is equal to 9. So the number of n, or the number of terms between 8 and 26, which are all odd integers, is 9. Since the first, the last, and the number of terms are all given, we can use the formula S of n is equal to n over 2 times the quantity of first term plus the last term. By substitution, we have 9 over 2 times 9 plus 25. So we have 9 over 2 times 34 is equal to 153. What is the sum of all the multiples of 3 from 15 to 48? Answer: 378. Solution: applying the same concept from the previous example, n will be equal to 12. And the sum is equal to 378.